In this video, I'm going to talk about synchronous up counters. First of all, what do you understand by a synchronous counter? A synchronous counter is a device in which all the flip-flops in the counter are clocked at the same time by a common clock pulse. As you can see it over here, the same clock signal has been given to flip-flop number 0 as well as flip-flop number 1. These are known as synchronous counters. Now, what is up counter? Up counter is a device which counts in the increasing order. As in the case of 2-bit synchronous binary up counter, it will count 0, 1, 2, 3, 0, 1, 2, 3 and so on. So this is up counter. For the designing of a 2-bit synchronous binary up counter, we require 2 JK flip-flops. To discuss the operation of 2-bit synchronous binary up counter, we will see the truth table. First of all, Q0. Q0 is going to toggle at every clock cycle. 0, 1, 0, 1, 0. That means flip-flop number 0 must toggle at every clock cycle. That is why J0 and K0 is connected with a high signal. On the other hand, what about Q1? Q1 is going to toggle here and here. Now, when Q0 is equal to 1, at the next clock cycle, Q1 is going to toggle. When Q0 is equal to 1, for the next clock cycle, Q1 is going to toggle. That means J1 and K1 is equal to Q0. When Q0 is 0, J0, K0, clock 1, output is no change condition, as you can see it over here. When Q0 is 1, at the next clock cycle, J1, K1 will become equal to 1. Clock is already 1, so Q1 will toggle. That is, the value of J0 and K0 is equal to 1 and the value of J1 and K1 is equal to Q0. Now this is the timing diagram of 2-bit synchronous binary up counter. We are considering the positive edge triggering over here. What is positive edge? When the edge is going from 0 to 1, this is known as positive edge, whereas when the edge is going from 1 to 0, this is known as negative edge. We are talking about the positive edge triggering timing diagram over here. That is, when the positive edge is going to come in our clock cycle, there is a change in Q1 and Q0. Now, for this 0 clock cycle, that is initial condition, both are reset condition. For the first clock cycle, Q1 is 0 and Q0 will change its value from 0 to 1. Second clock cycle 1, 0. Third clock cycle 1, 1 and the fourth clock cycle recycle condition 0, 0. Now the topic is 3-bit synchronous binary up counter. We require 3 flip-flops for the designing of 3-bit synchronous up counter. It will count total 8 conditions from 0 to 7. Starting from the initial clock value, every time we have to consider the reset mode. That is, all the outputs are set to 0. Now what about the connections of flip-flop number 0, that is J0, K0. Let us see the truth table. Q0 is going to toggle at every clock cycle, 0, 1, 0, 1, as you can see over here. So that is why once again it is connected with a high signal. Q1, exactly same operation as we have discussed in 2-bit synchronous binary up counter. When Q0 is 1, at the next clock cycle, Q1 is going to toggle. When Q0 is 1, Q1 is going to toggle. That is why, once again, J1 and K1 is equal to Q0. Now the last condition is Q2 that we are going to talk about over here. Now let us see the considerations. Here Q0 is going to toggle. Q2 is going to toggle, and here as well Q2 is going to toggle. So the condition is when both Q0 and Q1 are 1, 1, Q2 is going to toggle. When both Q0 and Q1 are 1, 1, Q2 is going to toggle. So we have used an AND operation over here. So when both the values are 1, 1, J2 and K2 will become equal to 1, 1 and Q2 will toggle. So this is the operation of 3-bit synchronous binary up counter. So you can see it over here. J0 K0 1, J1 K1 is equal to Q0 and J2 K2 is equal to Q0 dot Q1. Once again, the timing diagram has been designed for positive edge triggering. 0 0 0, 0 0 1 for the first clock cycle, for second clock cycle 0 1 0, third clock cycle 0 1 1, fourth clock cycle 1 0 0, fifth clock cycle 1 0 1, sixth clock cycle 1 1 0, seventh 1 1 1, and the last eighth recycle condition 0 0 0. 4-bit synchronous binary up counter. For the first 3 flip-flops, it will work exactly same as we have discussed in 2-bit synchronous binary up counter. That is, J0 K0 is equal to high, J1 K1 is equal to Q0, and J2 K2 is equal to Q0 dot Q1. Now let us see when our flip-flop number 3 is going to toggle. So this is the truth table. Now Q3 is going to toggle here one condition and here the second condition. So what is the condition now? When all the 3 outputs Q2, Q1 and Q0 are 1 1 1, there is a toggle condition. When all the 3 outputs are 1 1 1, there is a toggle condition. So the output will be J3 K3 is equal to Q0 dot Q1 dot Q2. When all the 3 outputs are 1 1 1, there is a toggle condition in Q3. So these are the values: J0 K0 1, J1 K1 Q0, and J2 K2 Q1 dot Q0, and finally J3 K3 is equal to Q0 dot Q1 dot Q2. For the timing diagram, you can practice the same by yourself, and you need to design total 16 clock cycles as per the truth table, and you can design the same for the positive edge triggering.